Hello everyone, my name is Pearl, Honey Pearl Ahapa, and you can call me Pearl. And my report for today would be all about patterns and diagrams, which is symmetry. So along the way, we would be able to know what are patterns, what are diagrams, what is symmetry in addition. So let's go ahead. Symmetry is a predictable and perfect regularity within pattern, and certain aspects of pattern are produced identically of the pattern that are changes. So as you can also know, when Ma'am Ubas explained to us that symmetry is actually equal. So here are the examples when we get to know about my report. You can see the examples of diagrams and symmetry, and I'll give you 15 examples later on, and I will be explaining it one by one as well. So yeah, let's go ahead and proceed here. So as what I've mentioned, there are 15 pattern and diagram types for symmetry. Traditionally, because you are dealing with symmetries, your pattern schematics would show symmetry operations. So I'll be explaining, as you can see on the top, these shapes there, the symmetry and the patterns. I'll be explaining that one later on one by one for you. So yeah, let's go ahead and start. The number one is P1 or P1, a symmetric type represented only by translations over shift. It produces simple shift patterns or P1 patterns. So as you can see on the top, there is actually a triangle which shows F, 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 F or P1. The second one is P2 or P211. Demonstrate an understanding of increasing patterns by describing and reproducing and extending and creating patterns using manipulative diagrams. So as you can see there is a pattern that is showing for the square one, right? And the third one is PM, or which would be calculated as P1MQ1. This is a graphical presentation of price movement by using series of trend lines or curve. So earlier you were able to see a triangle that's showing like that, but right now it is a straight line. So that is PM. The third one is CM, or we can say that this is C1M1. This is a mathematical object covering a whole Euclidean plane by repeating a motif. As you can see there on the top, it is a triangle one, but there is a repetition of a pattern showing it. It's called CM or C1M1 because of the repetition. Number 5 is PMM, or it could be called as P2MM. The aim of the present paper is to evaluate by means of nonlinear dynamic analysis for different procedures for the selection of sectional forces needed. So as you can see, earlier we've got this example, but right now it's a straight line. And the sixth sample is PMG, that is P2MG. A glide reflection is a compensation of translation and reflection where the translation vector is parallel to the line of symmetry. So there is a gliding there with PMG, as you can see on the top. So it was been encircled as well. PGG or P2GG. The glide reflection pattern consists of two transformations: reflection over the line, translation along taking line. So it has a glide reflection pattern consists of two transformation, as you can see there as well within the PGG, while the other one is only one. The eighth example is methodology or CMM. C2MM. The model describes a 5-level evolutionary path, increasingly organized and systematical, more mature processes. So that's the example pattern there on the top. It's actually a diamond shaped one. the ninth example is P4, or we call that one as P4, a symmetric type characterized by 90-degree rotations or quarter turns, produces pinwheel patterns. That is what it calls P4 because of the pinwheel patterns, and it's 90-degree rotational, so it could be rotated. The 10th example is P4M, a symmetric type characterized by 90-degree steel rotation with centers on reflection axis. So earlier, as what I mentioned, 90-degree. However, it doesn't have centers reflection, while our 10th example do have rotational. And 11th example is P4G or P4GM, characterized by 90-degree and 180-degree rotation, produces quarter turns and rotated mirrors pattern. So it was being rotated, as you can see on the top example there. It looks like a chain actually. And the 12th example, we're almost there, is the P3 asymmetric characterized by 120. Earlier it was 90 to 180. Right now we've got 120-degree rotation, which is the 3 rotation pattern. So that is why it calls P3, because it got 3 rotation on the patterns, as you can see on the top example. The 13th example is P3M1, or we call that one asymmetric type characterized by reflection in axis intersecting 60-degree and 120-degree, which would equal to 180-degree rotation around the center that lies reflection axis. Produces 3 mirrors, as you can see on the top. 1, 2, 3, right? The number 14th example is the P31M, asymmetric characterized by the reflection and axis intersection 60 steel and 120 rotation. However, it produces 3 rotation and mirror patterns. So earlier it's only mirror, but right now it produces 3 rotation and a pattern as well, as you can see on the top. And the last example would be the P6 or Primavera P6 software time-scaled logic diagrams. This one contains activity displayed in your Gantt chart in the format that displays the entire schedule. So as you can see on the top one, it displays the entire pattern for you to understand as well what is P6. So yeah, that would be all. My topic for today. I hope you guys would be able to understand and to comprehend it all about. So just a brief recap as well on what I've mentioned for today, and what I've explained for today. My lesson would be all about the patterns and the diagrams, the patterns, diagram, symmetry, that is presented by me. And we've got 15 examples earlier. The first one is P1, the second one is P2, PM, CM, PMM, PMG, PGG, CMM, P4, P4M, P4G, P3, P3M1, P3M1 again, and then 31M, I mean, and then P6. So that would be all for today. I hope you guys did learn something, and actually just as well a brief code, you would be able to see those patterns, symmetry, and diagrams on our natural life. So it doesn't just reflect, or it doesn't just pop up anywhere because it was been explained, or because it was been entirely discussed to you, but because we recognize these patterns every time, not just on our household but also everywhere you go. And I hope you guys would be able to appreciate the beauty of patterns and diagram as well. So yeah, I guess that would be it. Again, my name is Honey Pearl A. Hapay, and thank you for today, and thank you for watching my video. Bye.